All right, so the question Cassidy has is about office hours. So we're gonna just share this screen with you, which is our EDSB page for pre-algebra. So this is second period's EDSB page. So you see up here where it says for the week, it says this will be our plan for the week, Monday 4/13 to Friday 4/17. Office hours are from 2 to 3, and you'll use this Zoom code. All right, so if you have any questions after class that you run into, you can come back during those office hours, put in the Zoom, go to Zoom, put in this code and that password, and it's just an open Zoom where you can come and ask questions. So it's
Okay.
not or anything like the class, so I'm not like posting them, but it's like coming to get help at school. So if you have questions at that point, you can join us there.
Thank you.
Yep. Sending a quick message to someone in our waiting room, and then we'll get started on this. Okay. All right, so please make sure that you have the notes. Let me switch screens here. All right, so these are our notes for today, and they are still related to our slope-intercept form. But what we're looking at with these is we are looking at, see if I can get this to focus a little better. Yeah, that's better. All right, so we're still looking at slope-intercept form, but we're looking at it with word problems and how to write that and how to recognize word problems in particular as being something that we could use slope-intercept for. So just give me a thumbs up or a raised hand or something to say that you're ready to go. If you've got any questions, hopefully we can get those out of the way. So everybody ready to go? All right. Looks like we got most of you giving me thumbs up or raised hands or something. So if you go ahead and put those hands down then, unless you've got a question, you can leave it up. All right, so looks like Trevor, you still got a question, or are you just raising your hand to say that you're ready to go?
I'm just raising my hand to say I'm ready to go.
All right, thank you, sir. All right, and let's get one more from the waiting room here. Okay, so let's see. Mason still got his hand up. Mason, do you still have a question, or are you just saying you're ready to go? It's like hand down, so ready to go. All right, so let's get started on this. All right, so with slope-intercept form, that's the y equals mx plus b. It has those four parts, those four variables. So what we need to understand is what each variable represents and how we can recognize it then in a word problem. So the dependent variable, right? We talked about this, that every function that's linear for the most part has a dependent and an independent variable. And the dependent variable, if you recall, was always the y, right? What happened with y depended on what x was in most situations. And that's certainly the case here, is if we plug in some values for x, we're going to multiply it by m and then add b, and then it tells us what y is. So y depends on what x is. So y is our dependent variable. So when we're looking at word problems, we need to figure out what depends on the other thing in the situation that they're giving us. So the rate is usually stated in a word problem for slope-intercept form would be our slope, right? We've talked about slope being our rate of change between our y value compared to our x value change, right? That ratio. So our slope, or m in this, is our rate that will be stated in the problem, right? And rates are usually indicated by the words per, each, or every. Not that they can't be shown other ways, but those are the primary wording that will indicate that something is a rate for you. So, and at any point you got a question, guys, just give me raised hand. Remember, that's Control Y, or I believe Option Y on your Macs. So independent variable, as we talked about with the dependent being y, independent is our x. So in the situation where we look at a word problem and say, all right, this thing depends on the other, the thing that is independent will be our x value. So, and then the starting value in a word problem is what we would determine as our y-intercept or our b value, okay? So y, m, x, and b will all be represented by something in these word problems. So if we look at this first word problem, let me just get this so we can see the whole problem. Oops, maybe not. All right, so yeah, I think we can get the whole problem in there. So in this example, all right, this is a example of a word problem in slope-intercept form where we don't have this b value, where there's no starting value. So in this word problem, it says Zane walks 2 kilometers during each trip to school, right? This word right here, as I said, we're looking for per, each, every, perhaps to indicate our rate to us. So this word right here is going to indicate that what we're talking about, 2 kilometers each trip, is our rate. So 2 kilometers is going to be our m value. All right, so our m in this is going to be the 2 kilometers each trip. If we wanted to say it out completely as to what our rate is. And then it says, write an equation that shows the relationship between the number of trips and the total distance walked. All right, so it seems like we don't have a lot of information here to write our rule. So, but we do have the rate, so we have the m. What we need to determine is what is the y and what is the x. So we're going to try and determine that by asking a couple of questions, right? And the first question is, in the relationship they're asking us to write about, which of those things depends on the other? So does the number of trips depend on the total distance walked? Or does the total distance walked depend on the number of trips? So let's just zoom down on this a little bit. Sorry, my cats are deciding they wanted to fight right now. Hold on one second. Just gonna, all right, I think they're done at the moment. Sorry about that. It's the problem with living in a zoo, I think. So, does the number of trips depend on the total distance walked, or does the total distance walked depend on the number of trips? So, anybody tell me what they think about that? Raised hands. Anybody? All right. Let me just call on someone then real quick. So let me go to Andrew. Good morning, Andrew.
Good morning.
All right, so which of these do you think is the case? Do you think the number of trips depends on the total distance walked, or does the total distance walked depend on the number of trips?
I think it's the number of trips depend on the total distance walked.
Okay, so let's say, for example, says in the problem that he walks 2 kilometers to school. So if you're walking 2 kilometers to school each trip, right? If you make one, how far have you walked?
Wait, say it again because you like kind of cut out.
Okay, sorry. If you make one trip, how far have you walked?
2 kilometers.
Okay. So if you take 3 trips, how far have you walked?
I think you walked like 6 kilometers.
Okay. So does it follow that the number of trips would depend on the distance walked, or total distance walked depends on how many trips you're taking?
Yeah, I think it's the total distance walked.
Depends on, so the second question.
Yeah.
Okay, so this is correct. So that this is the no part of the question, and this is a yes. Yes, the total distance walked depends on the number of trips. So whatever depends on the other, distance usually depends on something else. Okay, so whether it's speed or time or number of trips in this case, distance is usually a dependent variable. All right, things like time and number of items usually is your independent. Okay, here's a indicate your independent variable. If you can recognize what your rate is early on, like we did, this says each trip. Okay, and if we think about this equation, right, if this is, like if I'm using this and saying that that is the 2 from this equation, right, our m is 2 here, right, this would be 2 times x, and each in this situation is actually a multiplication word. So this would be 2 times the number of trips. So the number of trips, whatever it is saying here in the rate, so if it says each, every, or per, right, whatever this thing is usually, I shouldn't say usually, it's always your independent variable. So in this case, we should know then that our independent variable is the number of trips, and our dependent variable then is that distance. Okay? Does everybody follow that? Give me a thumbs up if you're with me on that. So that this is telling us whatever number is here, or whatever wording is here after each or every or per in that rate is telling us the independent variable, and then the other is our dependent. So in this problem where it's asking us to show the relationship between the number of trips, the number of trips would be our x value, and the total distance walked would be our y value. So now I have defined for myself what each variable is representing and whether it's independent or dependent, and I have a rate. So in this problem, I said that these are a no starting value problem. If there was a starting value, there'd be something else with a number here. So I'm going to come down here, right, to the actual place where it says once I have an answer to both of these questions. All right, so let's finish going over these questions first. Sorry, this is a little crooked now. All right, so the answer to this question will determine which is the dependent independent, as we said. And is the 2 a trip rate or a starting value? And we already said that early up here because we recognized that each indicated a rate for us. So the 2 was a rate. So in this problem, I'm going to write just a very simple slope-intercept equation of y equals 2x. All right, I don't have a starting value, so I could say plus 0 if I wanted to, but it's not a requirement there, okay? So I want you guys to try that practice problem, and I'm going to give you like a minute or 2 here to try out that practice problem. And then if you've got an answer, you can give me a raised hand if you'd like to tell me what you got for that. All right, so when you're answering this question, remember, look for the rate, look for what depends on the other thing, right? And so in that problem, does the number of gallons depend on the total cost, or does the total cost depend on the number of gallons I purchased at the gas station? All right, so answer those questions. And then again, if you recognize the rate, the thing that it is per or each or every is also going to help you identify the independent variable, the X variable, okay? So go ahead and give that a try. Give you a minute or two here. Does anybody have a question? I see Trevor's got his hand up, but I'm assuming that's to answer my question, not to ask a question. If you've got a question about this, send me a message through chat and we can try and address it. All right, so Trevor is saying that he does want to ask or answer the question, so. All right, so looks like most of you, I don't have any other messages through chat here, so let's actually, let's see, one more. Oh, Trevor does have a question. Sorry, let's go to Trevor real quick. Trevor, what's the question?
Yeah, are we gonna go in like breakout rooms today or not?
Probably when we start the IXL, yeah.
Okay. I just wondering. All right. Thank you.
All right. All right, gonna come over here to Cassidy then. Cassidy, do you have a question or are you wanting to answer this question?
I want to answer the question.
Okay, so tell me what you got first of all, and let's then kind of go back and break down how you got that answer. Tell me what your answer to the question actually is here.
So I got M equals $1.89 per gallon.
So your M is 189. Did you write a Y equals equation then?
No, I just wrote M equals 189 pounds.
Okay,
per
so
pound.
you've you've identified this as your rate, correct?
Yes.
Okay. So the other thing we need to do then is determine in this situation which of these things in the relationship they're asking us to write, whether it's the number of gallons or the total cost, which of those things depends on the other. So does the number of gallons depend on how much I spend, or does how much I spend depend on how many gallons I buy?
The money you spend depends on how many gallons you buy.
Right, so my total cost depends on the number of gallons. So my total cost would be my Y value, that's my dependent. And then the number of gallons would be my X value, right? And the other place I can recognize what my X value is what it says it is per. So it is per gallon, that's my X value as well there, okay? So I can recognize it hopefully either way in that situation. So what would be my final actual equation with the Y and X involved in it then?
Would it be Y equals, where is it? Y equals 189. I'm sorry, $1.89.
Mm-hmm. And then what's following that?
X.
X, right. So $1.08, and we could put the money sign there or not. It doesn't necessarily matter as long as we understand that that's money we're talking about. So that would be how we would do that. So good job, Cassidy. Thank you.
you.
All right. Anybody have questions on that aspect of how to write one without a starting value? All right. Fairly straightforward because the number involved in that, you don't really have a whole lot of choice because the number involved in that is almost always going to be your rate, your slope, okay? All right, so let's take a look at the second example, which was the second sheet here. So let me just get to that. So in this problem, all right, it says a plumber charges $25 for a service call plus $50 per hour of service. All right, it says, it should say write an equation. Sorry, it doesn't say equation in there. It should say equation in there. All right, so write an equation for the total cost in relationship to the hours of service. And then it asks a second, or it asks the question, what will the total cost for 8 hours of, or what will be the total cost for 8 hours of work? All right, so before we can answer that question, we have to write the rule first and then evaluate the rule. So we're going to ask ourselves a couple of questions here again. First thing we want to do anytime we're dealing with a problem, a word problem, and they're asking us to write an equation, the equation is going to include at least one variable, and in this case, two, because it's asking us to write an equation about a relationship between two things. So the two things in that question, the total cost compared to the hours of service, is the first thing we need to ask ourselves. So in the problem here, it says, do the hours of service depend on the total cost, or does the total cost depend on the hours of service? All right. And I think if we kind of look back at the example or the practice problem we just did, total cost almost always depends on something else. It depended on the number of gallons. All right, total cost will depend on the number of items you buy if something all costs the same. So total cost is almost always a dependent thing, and time in some way is almost always independent. All right, so this is the one that is actually the case. Total cost depends on the hours of service. And if we weren't positive about that, once we define and figure out which one of these numbers, whether it's the 25 or the 50, is our rate, once we recognize the rate, we can use the thing that follows per, each, or every to determine whether or not we're correct about that, okay? So once we've determined this, all right, the total cost depends on the hours of service. So I'm going to come up here and say total cost is my Y value. All right, and my hours of service is my X value, okay? So second question we want to ask ourselves, is the $25 service call a rate, or is it a starting value? And then is the $50 per hour a rate, or is it a starting value? All right, hopefully we can tell just by what wording follows this, which one is our rate. All right, and that's this one because it includes that word per. All right, so $50 per hour is a rate. $50 each hour, $50 every hour. Every hour they charge $50. However that's phrased, okay, if it's including those types of words, it's going to indicate a rate. So this is our M here. That means that this $25 service call, which only gets charged one time, right, when they show up, no matter how long they work for, it's going to cost you at least $25 just for them to show up. All right, that's our starting value, or our B in this, right? It's our y-intercept in this slope-intercept format. Okay, once we have the answer to all these questions, we should be able to then kind of just go back and fill in our y. If this is y equals mx plus b, we're just going to replace all of these things with what we know. Well, y and x don't actually get replaced. We just hopefully understand what they represent. So y is our total costs. equal to that M is $50 times X, which is our number of hours, all right? And if, again, we weren't sure about this, per hour should indicate that X is our hours, plus B, well, B in this case is the 25, all right? So we have that slope-intercept equation. Does everybody follow me on that? Does anybody have a question on what I did there? Okay, doesn't look like any hands or chat is going, so I'll keep going on to the second part of this question, and that is what will be the total cost for up here 8 hours of work? So once I have this equation, I can now use it to evaluate for any total cost or total cost for hours even. So in this case, it's asking me about 8 hours of work. Well, if I've actually defined my variables and know that X is hours, I know I'm going to replace 8 or X with 8 to answer that question. So in the question, I'm just going to do this in red pen so you can see it a little better. I realize I'm not showing up great on this. So $50 times 8 hours plus the 25 will tell me the total cost at 8 hours. So assuming there's a big plumbing problem in your house and they work there for 8 hours, right? It's $50 times 8, which if you do the math there is $400, right? Plus 25. And so finally putting those together, we get that the total cost, and I'll put the money sign on this so that we know that that's actually money here, is going to be $425. Okay. Questions on how to evaluate once you have a rule. All right. If not, let's go ahead and try this practice problem here, and I'll read it to you guys just in case you're having trouble reading it at all, because it doesn't all fit on the screen completely. Says a water tank already contains 55 gallons of water when Baxter begins to fill it. Water flows into the tank at a rate of 8 gallons per minute. Write a linear equation to show the relationship of the minutes filling the tank to the total gallons of water in the tank. And then it says find the volume of water in the tank 25 minutes after he begins filling the tank. So once again, ask yourself, in this relationship, does the minutes filling the tank depend on the total gallons, or do total gallons depend on how long he's filling the tank? Okay, so ask yourself that question. Whichever one depends on the other is the Y value, and whichever one is not depending is your independent or X value. All right, and then decide whether or not this 55 gallons of water or the 8 gallons per minute is your rate, and which one is your starting value. All right, and then write out your Y equals mx plus b by replacing M and B with those values. And then once you're done with that, it's going to ask you this final question to find what happens after 25 minutes. All right, so I'll give you a minute or two to come up with our equation. Everybody got questions on this one? All right, I am going to open up a couple of microphones here so that people can, I'm going to call on a couple of people. So I'm going to open up Asher's,
Yes.
John's. So Asher and John, you both there?
Yes.
All right. So either one of you can answer. Which one of those things, minutes filling the tank or gallons of water, which one depends on the other one?
So what I wrote is y equals 8x plus 55.
Okay. In
I got
which one? Okay. And which one, Y represents which one? The minutes or the total gallons?
Minutes.
Y represents the minutes?
Gallons.
Okay. And
Oops.
how do we know that X represents minutes then? If this is our
Because it says per.
right, it says per minute. So that's going to be our X, right? Because this is really 8 times number of minutes, right? Per each or every means times in these situations. So 8 times X is what we would have in our MX plus B, right? So you guys are correct in that this is Y equals 8X plus 55. So Y is our total gallons. So that's our Y value here. Put that in red so we can see it a little better. So this is our Y value on that one, and X is our number of minutes because we see it there as well in the per. All right. Thank you, gentlemen. And let me come to, let's see. Imagine. Good morning, sir.
Good morning.
All right. So with that rule that we have there, have you been able to what we have?
My fault. Hold up. Sorry.
That's all right.
Hello.
You've got kids in your house. I've got cats, so sorry.
Yeah. Hello. What were you saying?
All right. So on this problem, have you been able to evaluate it for that 25 minutes?
No, I'm a bit confused on this.
Okay. So do you understand where this, and let me just open up Cassidy's as well, because she sent me a message that she's a bit confused. So Cassidy, you there?
No.
All right. So you said you're confused on this as well. Where did I lose you?
So what I got was Y equals 55 times 8 plus 25. So B would be 25. I think that's where I mixed up everything.
All right. So this 25 is not going to be part of the initial rule, okay? Because usually the third number in these is in that question sentence, or in this case, not necessarily a question, but a find sentence, right? This number is what you're going to use after you've written the rule to evaluate with, okay? So in other words, it's usually an X value they want you to replace. So notice it gives you a number of minutes, a number of gallons, and then a per minute. Gallons per minute is what each of these things represents, right? This 55 is the number of gallons in the tank initially, right? So that if it says already contains or starts with or begins with, right? That is a starting value, a beginning value, that plus B part, all right? Then this 8 gallons per minute, that per is going to indicate that it's our rate, our M. Okay. And then our rule is always going to contain a Y and an X. It's never not going to contain those two variables. We just have to know what those variables represent. And so in the case of the rate, it tells us per minute. Well, if our rate is times X always, right? Our MX is always part of that. That 8 per minute means that X represents minutes here. Okay, and that means Y is going to represent our total gallons in that tank.
Okay, thank you.
So then, imagine you follow that as well.
Yeah.
Okay, so then what am I going to do with this 25 at that point? Once I have this rule, what am I going to do with that 25? 25 goes. Is it going to go in place of the Y or in place of the X? Because if X
X.
is minutes, right? It says
Yeah.
25 minutes, so I'm now going to replace X.
With 25.
So I'm going to say, to evaluate this, I'm going to say that our total of Y is going to equal 8 times 25 plus 55. And so what's 8 times 25? Anybody, either of you?
200.
200.
Okay. 200 plus 55, and Trevor already sent me this through message that the final answer here is 255. So thank you, Trevor, for that answer a bit ago. And 255, oops, probably not really seeing this. 255, and what does 255 represent? 255 what are we talking about here?
Minutes. I
Volume
don't know.
of water.
Why? What's that, Cassidy?
Volume of water.
The volume of water, or in other words, the total gallons, right?
Yeah.
So gallons. All right, because gallons is a type of volume measurement, right? So, okay. So what we're going to do here is, anybody got any questions on that? Thank you, guys. I'll go ahead and mute you back here. Does anybody have any other questions on this? You can send me a chat. All right, so Ms. Carey, I'm going to go ahead and split people up so that we can take a look at our IXL section. And the IXL section, guys, we're going to work on today is in 8th grade. It's down in the Z section. It's Z14. And so let me just open that up. So if you want to work on that together in our groups here, I'm going to split you guys into some rooms. And in the rooms, you can share your screen with us if you need. So let me get you guys split into rooms here. We'll do 2 rooms again. So 2. And let's see. So let me get Miss Carey with her group here. All right, I think that's it. All right, and then assign this room. All right, so Z14, we're going to split into these rooms, and I'll jump in with the other room. Miss Carey, you're going to have about 4 in with you, all right?
Sounds good.
Hello.
Howdy. All right, so guys, in here, what I'd like to have happen is, as you're working on the IXL, if you've got a question, just let me know. You can ask me questions either verbally, or you can share your screen and show me what you're looking at there. We're just going to use the remainder of these, say, last 10 or 15 minutes to kind of work together on this. So if you need any assistance, just give me.
Mr. Peters,
Yes, Trevor.
look, I'm already at 95.
Okay, well then, if you want to, I mean, you're welcome to hang out and talk with people if you want, but you're done at this point then.
I want to get to 100 though.
Yeah, you can do that too.
Yo, Nate.
Oh, is that Trevor?
No, it's not.
Ah, bummer.
Mhm. Where's oh, Andrew? Andrew,
What?
what up?
It's Trevor.
Okay, snake, big slime. Okay. Come on, big snake, big slime. Ooh. Yo, yeah, come on. Oh, oh. Up, okay.
All right, guys, welcome back to the main room. Hopefully you got a good bit done on your IXL. If you didn't or were having some trouble, please remember to come see either myself or Miss Carrie at our office hours from 2 to 3 today or tomorrow even. The IXL is due by next class on Friday, so at 11 o'clock by Friday that IXL should be done, along with your homework. All right, the homework is a video to watch and complete the guided notes. So submit a copy of your guided notes to me on IXL, or sorry, not IXL, on EDSB by 11 o'clock on Friday as well. And then we'll go over those notes and do a bit of practice with that topic on Friday. All right, so thanks again for joining me today. Hope you got a bit out of it, and it's good to see you guys again. So see you on Friday. Fist bump. Out.